Hello, ladies and gentlemen. Welcome back to math. Today, it's a very simple video. Okay. Today, we're only going to go over identities. Okay. Just to give you guys a little more thinking of what they are, a little more understanding of what they do and how they work for the previous or for the next few concepts. Okay. So, our objective for today is to understand how the trigonometric identities work. We are usually familiar with three very basic ones, okay? Which is so, ka, to, okay? Sounds kind of weird. It's not another language, okay? It's abbreviations, okay? Just to keep you, to make it a lot easier to understand how some of the basic identities work, okay? So it goes, let me see if I can have a little board here. Here we go. All right, so our first one, before we get started on what's back here, our first word is, just to recap, okay, the ones we already know, which is so, okay, which is sine equals, so sine equals opposite, which is O, and then the H is hypotenuse, okay, that's so, and then we have ka, CAH, okay, CAH, which is cosine, equals adjacent over hypotenuse. Okay, so cosine, adjacent, hypotenuse. So ka, and then to. Not, all right, which is to. Which again is tangent equals opposite over adjacent. Okay. Now that we know the very basic identities, which is a little recap because we covered them when we did trigonometry. Today we're gonna do a little more complicated or more complex, okay, identities. So these are all also very basic identities, okay. We have quotient, reciprocal, and Pythagorean, okay. Keep in mind, guys, four quotient identities, okay. You guys saw the unit circle. You guys know how to work the unit circle now, okay. Now that you know how it works, for quotient identities, we have tangent theta equals, okay, sine theta over cosine theta, okay. So we have sine over cosine. That's in order to find tangent, okay. To find the opposite, which is cotangent, okay, cotangent theta equals the opposite, cosine theta over sine theta, okay. All we did is flip, okay, your pieces in there, and again, the opposite of tangent is cotangent. For the reciprocal identities, okay, it says it on the name. Reciprocal means the opposite, okay. So cosecant, okay, it says cosecant is 1 over sine theta, okay. So if you wanted to go from sine, okay, to cosecant, it would be the opposite, okay. So therefore, secant equals 1 over cosine theta, and finally, tangent equals 1 over cotangent theta. Oh, my bad. We did it opposite. Cotangent and tangent. Okay. Obviously, the opposite would be flipped. okay? If you were finding the very basics of it, okay? If you were turning this into this, it's the opposite. You flip them. So you flip this to make it sine, okay? You flip it to make it cosine, and you flip it to make it tangent, okay? For Pythagorean identities, this is a little more complicated, okay? A little more complex. When it comes to Pythagorean identities, we have cosine theta, okay, cosine squared theta plus sine squared theta equals 1, okay? We have tangent squared theta plus 1 equals secant squared theta, okay? So when it comes to a problem where you have cosine squared theta plus sine squared theta, all that, just another way of saying 1, okay? When you have tangent squared theta plus 1, it's like all you're saying is secant squared theta, okay? When you have cotangent squared theta plus 1, you can convert it, or it's just like saying cosecant squared theta, okay? Again, all we want to focus on today is knowing SOHCAHTOA, okay? Knowing that tangent is like saying sine over cosine. Cotangent, cosine over sine, this is the opposite. Cosecant is 1 over sine. Okay, secant is 1 over cosine. Cotangent is 1 over tangent. Okay, and then our little more complicated ones, which is cosine squared theta plus sine squared theta is just like saying 1. Okay, these ones are going to make more sense once we start getting into that last concept. Okay, but keep in mind, guys, all we have to do is convert. These are identities we need to get familiar with. Okay, our problem for today is we're trying to simplify. Okay, something very, very simple. We'll start with something as cosine theta times secant theta. Okay, so cosine theta times secant theta. This means that, okay, if you really look at this problem, cosine, it's already at its purest form, okay? When it comes to sine, cosine, and tangent, okay? They're always at their purest form. So there's nothing really to do to cosine. So all we're going to do is leave cosine. Times, now look at secant, okay? The secant can be converted on that chart. If you look on reciprocal identities, which is the middle one, okay? There's cosecant, secant, and cotangent. The one in the meter, secant, it says 1 over cosine theta, okay? So another way of saying secant is 1 over cosine theta, okay? Notice that cosine, whenever there's a full number, there is a 1 under, okay? So we can say that if we have cosine, okay, we have secant, which the opposite is cosine, notice that we can cancel out cosine on both sides, on the bottom and on top, okay? We're left with 1 over 1, which technically becomes just 1, okay? This is why I say sometimes we're going to solve for them, sometimes we're only going to simplify them. This one we actually solved it because it became 1, Notice that we cancel out something from the top, something from the bottom that was the same. All right, this was a very, very simple one, okay? Keep in mind, again, we saw for it. Now let's do something a little more complex. Let's do okay? Again, keep in mind, guys, when you have something like this, theoretically, you could cancel it out because look, we have something similar. But since you're dealing with two, break it into two pieces, okay? We have CSC theta over CSC theta, which is cosecant, minus sine theta over cosecant theta. Okay? I will say this. When you cancel this out, it all becomes 1. Okay? Technically, cosecant theta can go to cosecant theta one time. Okay? So we have 1. Let's use another color here. We have 1 minus sine theta over cosecant theta. Since we are dividing these two, we could say sine theta over 1 times cosecant can be created into another problem, okay? If you look again on the chart, for cosecant, we have 1 over sine. So this becomes 1 over sine theta, okay? Again, well, technically we're still dividing. We're still dividing here. But since we're going to multiply, okay, we're going to flip the second one. It's going to become sine theta over 1 times sine theta over 1. Since you have the same thing twice, sine theta times sine theta, it's just sine theta squared. So technically our problem becomes one minus sine theta squared. Okay? Probably was the wrong marker to choose there. Baby blue. So we have 1 sine theta squared. Okay? So far. Just remember, this became 1. This became sine over cosecant. Cosecant became 1 over sine. Okay? Since we have division, we ended up making a multiplication. Therefore, we flip the 1 over sine. Always, always flip your second problem. Okay? When it comes to division, convert it to multiplication. Remember, that's the rule for changing division into multiplication. Now that we have 1 minus sine squared theta. If we look at that chart again, if we really, really look in there, there is 1 in there that is kind of like this. Okay? The only difference is it is positive on your paper. Okay? We're going to leave it like this. Okay? We're not actually going to convert it because we already have a sign there. Okay? We're trying to convert it as much as we can. The only reason is if you can convert it to just a simple term, that is fine. But here, since we cannot convert it to one term, it's still going to be 2 terms. We're just going to leave it as 1 minus sine theta squared. Okay? All right. so let's do one more just for that practice. Make sure you have everything written down. If you didn't, go back on the video, pause the video a little so you guys can write down all the notes. All right, for our last problem, we have, let's use black again. We have sine square theta over 1 plus cosine theta. Okay? Keep in mind, again, in order to make sine square theta into its purest form, we can take out two sine thetas, right? Because sine theta times sine theta makes sine, sorry about that, sine square theta. So it's like saying sine theta times sine theta over, if we look at the chart, this can pretty much be converted. 1 plus cosine theta. Okay? Which, if we convert this, 1 cosine theta, it becomes 1, which becomes sine square theta. Because we have cosine square theta plus sine square theta equals 1. If we move that 1 to the other side, okay, it pretty much becomes sine square theta from the chart. So it has sine square theta, which technically sine square theta becomes again sine over sine. So technically your answer is just 1. Okay. All right, guys. So again, you need to really look on those charts, okay, to convert your problems. All right. So I'm going to give you guys your assignment for today. Your assignment for today is number 1, CSC square theta minus 1 over cotangent theta. Number 2 is tangent theta times cosine theta. And number 3, cosine theta times secant theta over tangent theta. Okay? All right, make sure you convert them as much as you can. Simplify, in other words. Okay, if you have any questions, let me know. As soon as you're done watching the video, make sure you submit your answers and your notes. Okay, guys, I'll be here waiting for your email.